You think the biggest challenge of traveling to Mars is surviving on its frozen, barren surface. You picture crystal domes, crops growing in red dust, and the slow construction of a new civilization. That vision has been sold to you. A romantic version of space exploration built by movies and popular culture that deliberately ignores one inescapable physical truth. Mars will almost certainly kill you in the most violent way imaginable, long before your boots ever have the chance to touch its soil. Outer space is not a peaceful void. It is a high-energy radioactive firing range. The instant you leave Earth's protective magnetic bubble, your body becomes an open target for galactic cosmic rays and solar radiation storms. This is not a sunburn. These are subatomic particles traveling at a significant fraction of the speed of light, punching through your spacecraft's hull and shredding your DNA strand by strand during the dark months of transit. But suppose you survive the journey. Suppose you reach Martian orbit. That is exactly where thermodynamics and fluid mechanics have laid a lethal trap specifically for you. Mars's atmosphere is a genuine physical paradox. It is dense enough to generate colossal heat and incinerate your spacecraft into burning plasma at thousands of degrees, but it is far too thin to slow you down. Its atmospheric pressure sits at barely 1% of Earth's. This is the worst possible physical scenario. Enough gas to set you on fire, but nowhere near enough to open a parachute and arrest your fall. To understand how Mars plans to destroy you, you first need to understand what it truly means to move mass through the cosmos. Forget the constantly humming engines you see in science fiction films. That is an insult to orbital mechanics. Space travel, at its most fundamental level, is an exercise in relentless ballistics. You are a bullet fired from Earth, falling freely through the dark and silent void of the solar system. This leads directly to the first unbreakable principle of physics you must absorb today. Energy never disappears. To reach another planet in any reasonable time frame, you must inject an enormous quantity of kinetic energy into your vessel. You travel at tens of thousands of kilometers per hour. That energy belongs to you, but the universe is a ruthless creditor and always collects its debts. To stop when you arrive at your destination, you must shed every last fraction of that colossal energy. Think of a car on a highway. You press the brake pedal, the pads grip the discs, and kinetic energy converts into heat that dissipates into the air. Basic logic. But you are a spacecraft approaching a celestial body at 20,000 kilometers per hour in a total vacuum. There is nothing to brake against. No surface to drag your cosmic wheels across. You might think the obvious solution is firing your engines in the opposite direction to decelerate gradually. It sounds rational. But physics is governed by the absolute tyranny of the rocket equation. To carry enough fuel to fully brake upon reaching Mars, you would need an enormous vessel at launch. And to lift all that extra mass, you need even more fuel at departure, which adds more weight, demanding still greater thrust. It is an infinite mathematical spiral that makes self-powered deceleration physically impossible to engineer at any practical scale. Since pure mathematics forbids stopping under our own power, we are forced to use the planet itself as our brake. We use its sky. This technique is called aerobraking, and it is simultaneously elegant and brutal. We direct the craft not toward the rock surface, but through the upper layer of gases surrounding the planet, converting kinetic energy into searing heat, using an alien atmosphere as a planetary brake pad. On Earth, this works beautifully. But Mars is something else entirely, and what awaits you there defies every instinct you have. Aerobraking works on Earth because our atmosphere is thick, dense, and heavy. It wraps around any returning capsule like a wall of liquid. A heavy spacecraft re-entering terrestrial air slams into this resistance, wraps itself in a brilliant plasma bubble, and decelerates dramatically, enough for fabric parachutes to deploy and float the vehicle safely down to the ocean surface. The density of Earth's air provides the physical resistance to make all of this possible. Now look at Mars. That small red dot in the immensity of space is not a protective refuge. It is a dead world with a ghost for an atmosphere. The air pressure on Mars's surface equals what you would experience on Earth if you climbed to the stratosphere, more than 30 kilometers above sea level. It is nearly a perfect vacuum. And yet, here lies the irony that will kill you. It is not an absolute vacuum. That meager, thin layer of carbon dioxide is simultaneously the only thing available to save your life and the very weapon that will destroy you. You approach a rock abyss at hypersonic velocities, depending on a safety net made almost entirely of nothing. When your heat shield pierces that faint gas layer at thousands of kilometers per hour, the carbon dioxide molecules have no time to move out of your path. You strike them with inconceivable violence. And here is where popular culture has fundamentally misled you. It is not friction that burns you, not the way rubbing your hands together generates warmth. What destroys you is pure, extreme physical compression. You are crushing the air in front of your vessel so rapidly and so brutally that the immutable laws of thermodynamics dictate its temperature must explode to thousands of degrees. You are forging a sun of burning plasma in the millisecond before impact, directly in front of the fragile metal wall, separating you from the end of your existence. Many people watch space agencies successfully land robotic vehicles on Mars and make a catastrophic mental error. They assume that because we can land a small rover, landing a crewed spacecraft is simply a matter of scaling everything up slightly. That assumption will sign your death warrant. The fundamental problem is mass. A robotic rover weighs roughly 1 metric ton. Keeping a human crew alive and mentally stable across months of interplanetary transit requires an immense vehicle. Continuous life, support systems, tons of water, heavy shielding against deep space radiation, backup engines, and rooms full of physical provisions. We are discussing a metal fortress of 40 to 50 metric tons dropping from the sky. This is where the most basic geometry in the universe becomes your executioner. Call it the scale problem, a physical reality dictated by the square cube law. When you double the size of a spacecraft, its exterior surface area, the heat shield facing the Martian air, multiplies by 4. But its internal volume, and therefore all the mass it contains, multiplies by 8. As you design a vehicle large enough to carry human beings, its weight grows astronomically faster than its capacity to generate aerodynamic resistance. The area pushing against the air does not increase at the same rate as the weight driving you toward the ground. Physicists call this the ballistic coefficient, the ratio between an object's mass and the surface area it presents to oncoming air. A sheet of paper has an extremely low coefficient. Release it and it floats gently to the ground. A lead bullet has a very high one. It cuts through wind and stops for nothing. Your crewed spacecraft is not a cosmic leaf. It is a cannonball of monstrous proportions falling through an atmospheric cobweb, and that cobweb simply does not have the physical strength to catch you. The Martian carbon dioxide atmosphere, with its pathetically low density, lacks the physical force required to absorb the colossal momentum of a 50 metric ton mass. And the physical nightmare deepens further, leaving you with no escape route. On Earth, our thick atmosphere acts as a deep liquid cushion. It decelerates any heavy capsule until thermal friction completely disappears and the vehicle reaches terminal velocity. A constant, manageable falling speed, slow enough for enormous fabric parachutes to deploy without tearing themselves apart. On Mars, that nightmare unfolds differently. You never reach a safe terminal velocity in the upper atmosphere. That is the disturbing truth this planet holds. You tear through the entire atmospheric layer and approach the solid rock surface, still traveling at supersonic speeds. The ground is only a few kilometers from your face, and you are still moving at thousands of kilometers per hour. In desperation, suppose you deploy a parachute system. What happens when you open an enormous sheet of fabric in a supersonic airstream? At those velocities, air stops behaving like a gentle, flowing gas. Molecules strike the fabric with brutal impact force. A violent shockwave forms directly at the center of the canopy. In less than a fraction of a second, the dynamic pressure tears the material apart. Advanced polymer ropes shatter and disintegrate as though they were thin threads of sugar caught in a bomb's blast wave. The hard truth is that no parachute can save a massive object from the incomprehensible fury of the Martian sound barrier. When conventional aerodynamics has sentenced you to death, and with the rock surface filling your forward window, you have only one remaining option, one that violates every survival instinct you possess. You must use fire. This technique is called supersonic retropropulsion. It means igniting powerful rocket engines against your direction of fall while you are still traveling faster than the speed of sound. Imagine driving a vehicle at 1,000 kilometers per hour and attempting to stop by firing an enormous cannon of flame directly forward, all while driving through a wall of solid wind. The fluid dynamics of this maneuver reveal a genuine mathematical nightmare. Falling at supersonic velocity, Martian air collides with the base of your craft and creates a violent shockwave, an invisible barrier of extreme pressure. Directly inside that aerodynamic chaos, you ignite a stream of burning gas, pushing in exactly the opposite direction to the wind battering you. Fluid physics tells us that disaster follows. Your rocket exhaust collides with the supersonic airstream rising toward you. The flames have nowhere to go cleanly. They are pushed violently back upward, licking the sides of your own vessel and wrapping the entire structure in a cocoon of extreme turbulence. Your own engines create a virtual shield of hot gas that completely alters the aerodynamic shape of the vehicle. Instead of falling like a stable water droplet, your craft now behaves like a heavy hammer thrown handle first, intrinsically unstable. The entire vessel begins vibrating and oscillating with a fury that threatens to tear apart every weld in your hull. You are shaking inside a metal cylinder wrapped in your own exhaust flame, and the surface is seconds away. This is the point where your last real instruments, the radar altimeters meant to measure your precise distance from the ground, encounter their own destruction. You are firing engines so powerful that the extreme heat has created a bubble of partially ionized gas around your ship's base. Plasma and superheated particles act as a distorting mirror for radar frequencies. And as if that were not enough, the sheer force of your engine striking the surface below launches thousands of tons of oxidized dust into a blinding sandstorm moving at hurricane speed. Your radar signals bounce off the dust cloud, reflect off your own plasma envelope, and return to onboard computers as meaningless white noise. Your altimeter is losing its mind. The electronic brain of your vessel, the system that must calculate the precise thrust required millisecond by millisecond, is completely blind. You must reduce your velocity to exactly zero at the precise moment your landing legs touch the dust. Fire the engines a second too early and you fall like an anvil, the structure collapsing on impact and shattering your bones instantly. Keep them burning a second too long and the craft bounces and rolls. All of these must be resolved in total blindness, trusting algorithms, predicting chaos with no margin for error. You are 50 meters from the surface. Alarms are screaming. Radar blinded by your own plasma and the dust storm you created. And at this critical moment, you might imagine Earth's finest engineers in a vast control room, sweating over consoles, sending desperate correction commands to stabilize your descent. Break that illusion immediately, because the structure of space and time makes it physically impossible. You are completely alone, and the reason is not a technical failure in your antennas. The reason is the speed of light. That universal speed limit of nearly 300,000 kilometers per second is not a mere suggestion. It is the absolute and unbreakable law governing causality in our universe. Information, matter, radio signals, nothing travels faster. Depending on the orbital positions of our planets, signals take between 3 and 22 minutes to cross the void separating Earth from Mars. Your entire atmospheric descent, from first hypersonic contact to surface touchdown, lasts approximately 7 minutes. Let that temporal atrocity fully settle in your mind. At the precise instant engineers on Earth receive the first radio signal indicating you have grazed Mars's atmosphere, you have already been on the surface for minutes. If you miscalculated, if your craft tumbled and shattered into burning fragments, you are already dead. And yet on Earth, your colleagues are still watching their monitors, waiting anxiously, believing you are still falling through the sky. During those 7 minutes of terror, you exist in a kind of macabre limbo for the rest of humanity. You are a temporal ghost. No one can transmit a correction command because by the time that signal crosses space and reaches your computers, the future will already have happened. The universe has isolated you inside a prison of time where no brilliant mind on any other planet can throw you a lifeline. The outcome is already determined. Only you don't know which outcome it is yet. Now suppose the impossible occurs. Suppose physics granted you a momentary reprieve. Your computers did not fail. The plasma cleared just enough. The dust settled for a fraction of a second. You shut down the engines at the exact right millisecond, and your landing legs find the ground. You look through the window and see a blue dawn over an immense red desert. You exhale. You believe you have conquered the planet. That relief will be the most dangerous thing that has happened to you since you left Earth. Because you just survived orbital mechanics and fluid dynamics only to deliver yourself into the hands of inorganic chemistry and particle physics. The hard truth about Mars is not that it is merely a difficult place to inhabit. The matter composing the planet itself is architecturally designed to annihilate your biology. Popular culture has convinced you that Martian soil is simply dry dirt, that if you add water and some terrestrial compost, you can grow food and build an idyllic extraterrestrial garden. That is one of the most dangerous and naive misconceptions in all of space exploration. Spectroscopic data from our instruments reveals the true nature of that red dust. It is saturated with chemical compounds called perchlorates, salts derived from perchloric acid. On Earth, we use these unstable substances to manufacture solid rocket fuel and powerful industrial explosives. On Mars, they blanket every centimeter of the landscape visible through your window. But the truly lethal horror is not that the poison is simply lying on the ground. The deadly mechanism is electromagnetic force. Mars is an extraordinarily dry world, incomparably more arid than the most punishing desert on our planet. When ceaseless Martian winds sweep that ultrafine dust across the plains, constant friction strips electrons from surface particles. The entire dust field becomes electrostatically charged. Think about rubbing a balloon against your clothing and watching it cling to a wall through pure electrostatic attraction. Now apply that same physical force to a toxic, abrasive, microscopic powder surrounding you completely. Step outside your craft in your spacesuit, and basic physics dictates that you immediately become a human magnet. Electrically charged dust clings to your suit fabric, to the airtight seals of your helmet, to the valves of your oxygen supply. You cannot simply brush it away or shake it off. It adheres at the electromagnetic level. When you re-enter your habitat, pressurize the airlock, and remove your suit, that dust inevitably becomes airborne in the enclosed atmosphere you breathe. Once inside your lungs and bloodstream, perchlorates become chemically aggressive. They directly attack your thyroid gland, completely blocking iodine absorption. Your cellular metabolism collapses progressively. Neurological systems begin failing in sequence. You will not die in a glorious explosion, as cinema suggests. You will slowly dim, suffocated, and poisoned by the very dust of the world you came to conquer. And while your internal biology battles perchlorate toxicity, the universe launches its second assault from above. You might think that standing on a planetary surface inside a metal habitat provides protection from the radiation that threatens you in deep space. You are wrong again, and the reason reveals a particle physics paradox that destroys common sense entirely. Earth possesses a liquid iron core in constant motion, generating a colossal magnetic field, an invisible shield deflecting the radioactive fury of the cosmos. Mars's geological core is inert. No fluid movement, no dynamo effect, no magnetic protection. Galactic cosmic rays, massive particles traveling near light speed, strike the surface completely unfiltered. Your survival instinct will tell you to build thicker metal walls for your habitat. You might think that lining your base with heavy aluminum or lead plates will stop the radiation. In doing so, you will have constructed your own subatomic execution chamber. When a high-energy cosmic ray strikes the heavy atomic nuclei of your shielding metal, it does not stop peacefully. It collides with such violence that it shatters the metal atom's nucleus entirely. This collision generates what physicists call a secondary radiation cascade. The shield absorbs the initial cosmic bullet but explodes in doing so, sending a spray of subatomic shrapnel into your living space. Fast neutrons and lethal gamma rays flood your sealed interior. By attempting protection through conventional dense shielding, the immutable laws of particle physics dictate that you actually multiply the radiation dose reaching your organic tissue. Your protective barrier has become the precise weapon that will dismantle your DNA strands behind closed doors. Trapped inside a metal enclosure that multiplies your exposure to secondary radiation while breathing air laced with lethal perchlorates, you might still believe the situation is manageable. A set of serious but solvable engineering challenges. Fluid mechanics has one final card to play, and it can kill you in fractions of a second without any warning whatsoever. The greatest threat in this alien world is not what enters your suit from outside. It is what happens to the pressurized environment surrounding you when that pressure suddenly disappears. Atmospheric pressure on Mars is so catastrophically low that it crosses a lethal thermodynamic boundary that aerospace physicians and physicists call the Armstrong limit. To understand the full gravity of this, you need to recall that the boiling point of any liquid is not a fixed, unchanging number. It depends entirely on the pressure of the gas pushing against it from outside. On Earth, the heavy column of our atmosphere presses against your skin and holds the water in your cells in liquid form. As you reduce ambient pressure to extreme levels, water requires progressively less thermal energy to break its molecular bonds and transform into vapor. The vapor pressure of your body fluids exceeds the external force containing them. On the Martian surface, where pressure is nearly non-existent, the boiling point of water drops dramatically, falling below 37 degrees Celsius. And 37 degrees Celsius is, with macabre precision, your own internal body temperature. Popular culture has shown you heroic astronauts suffering a suit breach, patching the hole with their hand while continuing to work as if nothing significant occurred. The unbreakable laws of thermodynamics have no tolerance for that kind of fictional convenience. If your habitat pressure fails or your suit fabric tears suddenly and exposes you to the exterior environment, you will not suffocate peacefully. Your own thermal energy becomes your immediate executioner. The instant your body loses pressurization, the protective moisture in your lungs, the saliva on your tongue, and the fluid in your eyes will reach their boiling point simultaneously, using only the heat generated by your own metabolism. Contrary to the most persistent visual myths, your body will not explode, because human skin is mechanically elastic and remarkably resilient. However, the nitrogen gas dissolved throughout your bloodstream will expand with uncontrollable violence, forming massive lethal bubbles that block your circulatory system completely, a process called ebullism. The volume beneath your skin will expand grotesquely from accumulated gas. Your tissues will swell. Your pulmonary passages will collapse under explosive decompression. Your brain, the only organ that makes you human, will cease receiving usable oxygen within 10 to 15 seconds. You will lose consciousness long before you can understand what went wrong. Pure physics will erase your existence using phase transition rules to convert the water in your cells into lethal vapor. This is not pessimism. This is not an argument against human ambition or the exploration of space. It is what the equations actually say about our nearest planetary neighbor. A world that is simultaneously our most accessible destination and one of the most comprehensively hostile environments physics is capable of constructing. Every barrier described here, from the rocket equation to perchlorate chemistry to the Armstrong limit, represents the universe operating exactly as it was always going to operate, indifferent to our dreams and perfectly consistent with its own rules. Understanding these realities is not the end of the conversation about Mars. It is the only honest beginning of it. The engineers and scientists working on crewed Mars missions are not ignorant of these constraints. They are wrestling with them daily, because the only path to surviving Mars is to respect, completely and without illusion, exactly what Mars is. If this kind of unfiltered, physics-first truth is what your mind demands, if you are finished with comfortable science fiction and ready for the cold, precise reality of how the universe actually operates, then subscribe. Share this with someone whose understanding of space deserves the same upgrade, and stay with us. Because the cosmos holds far more of these truths, and we are just getting started.